At 6:04 in the evening on June 24th, 2026, the ground beneath Venezuela moved. A magnitude 7.2 earthquake, one of the largest to strike this country in living memory, ruptured a fault deep beneath the surface near the town of Umare. Buildings swayed in Caracas, 150 kilometers to the east. People grabbed their children. They ran for door frames. They stumbled into the streets. And then, before the shaking had even stopped, 39 seconds later, a second earthquake struck. Magnitude 7.5, closer to the surface, more powerful. And it hit a population that was already off balance, already disoriented, already in the worst possible position to survive what was coming next. The buildings that had been weakened by the first earthquake, the ones with cracked walls, fractured columns, compromised foundations, did not survive the second. They came down. Dozens of buildings collapsed across Caracas. The coastal city of La Guaira was devastated. Simón Bolívar International Airport, the main gateway in and out of the country, was structurally damaged and shut completely. A tsunami warning was issued for Puerto Rico and the Virgin Islands. The death toll, as of June 26, 2026, stands at over 920 people. More than 40,000 are reported missing. The number is still climbing. This is Venezuela's deadliest earthquake disaster in over a century. But what made it so catastrophic was not just its power, it was its timing. This is the story of what happened beneath Venezuela on June 24th, and the rare, devastating phenomenon that turned one earthquake into something far worse. To understand what happened, you first need to understand what an earthquake doublet is. Because what struck Venezuela on June 24th was not just one earthquake. It was not an earthquake followed by an aftershock. It was something rarer, something more dangerous, and something that, even today, is not fully understood. A doublet occurs when two separate earthquakes of similar magnitude on nearby or adjacent faults strike within seconds or minutes of each other. Not one main shock followed by smaller aftershocks. Two main shocks, back to back. Harold Tobin, director of the Pacific Northwest Seismic Network and professor at the University of Washington, described it this way: the seismic waves from the first one were not done yet when the second one happened. Think about what that means. The first earthquake sends out waves of energy, P waves, S waves, surface waves, radiating outward from the rupture point at thousands of kilometers per hour. Those waves are still moving through the ground, still shaking the foundations of buildings, still rattling the bones of the earth beneath Caracas when the second earthquake fires. The shaking from the first had not ended, and the second was already beginning. For the people of Venezuela, there was no gap, no moment of relief, no chance to assess damage, check for injuries, or get to safety. There was only continuous, compounding, escalating violence from the ground beneath them. Christine Goulet, director of the USGS Earthquake Science Center in California, was direct. It is very distressing that there was basically no time to evacuate. That is extremely unfortunate. That phrase, "no time to evacuate," is the key to understanding why this earthquake was so much more deadly than its magnitude alone would suggest. Now we need to talk about the fault, because the earthquake doublet did not happen randomly. It happened here in Venezuela, for a reason that has been building for millions of years. Beneath northern Venezuela, two of the largest tectonic plates on Earth are in permanent slow-motion collision. To the north, the Caribbean plate. To the south, the South American plate. These two plates are not colliding head-on, one diving beneath the other, as happens in subduction zones. They are sliding, grinding, moving horizontally past each other in opposite directions along a boundary that geologists call a strike-slip fault system, the same fundamental mechanism that drives the San Andreas Fault in California. The Caribbean plate moves eastward relative to the South American plate at approximately 2 centimeters per year. That sounds slow, and in human terms, it is. But 2 centimeters per year, sustained over millions of years, across a fault system 1,400 kilometers long, accumulates an enormous amount of stored energy. Energy that cannot release gradually. Energy that locks into the rock, builds pressure for decades or centuries, and then releases all at once. That release is an earthquake. The specific fault system involved in the June 24th doublet is called the Bocono San Sebastian El Pilar fault system. It is a complex, interlocking network of right lateral strike-slip faults that stretches for more than 1,300 kilometers across northern Venezuela. From the Venezuelan Andes in the west, across the central and northeastern coast, all the way to Trinidad. The June 24th ruptures occurred within a fault triangle bounded by the Bocono Fault to the south, the Oca Ancon Fault to the north, and the Bucaramanga-Santa Marta Fault to the west. It is precisely the kind of geometrically complex, densely connected fault network where doublets are most likely to occur. And Britannica's scientific analysis makes clear why. The rattling caused by the rupture along the first fault increased the stress along the second, which was located closer to the surface, until the rocks gave way. The first earthquake did not just shake the ground. It loaded the second fault. It pushed it past its breaking point. It caused the second earthquake to happen. In the language of seismology, the first event triggered the second. 39 seconds was not a coincidence. It was physics. The depth of the second earthquake is what made it so destructive. The first earthquake struck at a depth of approximately 20 kilometers, deep enough that some of its energy was absorbed by the kilometers of rock above it before it reached the surface. The second earthquake struck at a depth of just 10 kilometers, half as deep. In seismology, depth is everything. A shallow earthquake, one that ruptures close to the surface, delivers its energy to buildings and infrastructure with far less distance to lose intensity. The shaking is more violent, more sudden, less attenuated by the rock above. A magnitude 7.5 at 10 kilometers depth is a categorically different experience on the surface than a magnitude 7.5 at 50 kilometers. And this second earthquake, the shallower, more powerful one, arrived when the buildings of Caracas and La Guaira were already compromised, already cracked, already structurally weakened by the first event 39 seconds earlier. Structural engineers have a term for this: cascading failure. When a building absorbs one large seismic event, it may appear intact from the outside, but internally, columns have fractured, connections have slipped, load-bearing walls have cracked. The building is standing, but it is standing in a fundamentally weakened state. Its capacity to resist the next event has been dramatically reduced. The next event arrived 39 seconds later. In parts of southeastern Caracas, nearly all high-rise buildings sustained heavy damage or collapsed entirely. Not some, nearly all. That is not the result of one earthquake. That is the result of a doublet. The first event stripping away the structural capacity of the buildings, and the second event finishing what the first began. I had been warned. not specifically about June 24th. Science cannot yet predict the day, the hour, the minute of an earthquake. But the broader warning was there, in the historical record, in the geological data, in the pattern of previous events along the same fault system. This fault has been active for a very long time. In 1641, a large earthquake struck along the El Pilar Fault to the east, destroying the city of Cumana. In 1766, another significant event struck the same region. In 1812, the most catastrophic in Venezuela's recorded history. A massive rupture along the Boconó fault system destroyed much of Caracas and Mérida, killing between 15,000 and 26,000 people. In 1900, a magnitude 7.7 earthquake struck, the most powerful in the country's modern seismic record until now. In 1967, a magnitude 6.5 killed around 280 people in Caracas and collapsed apartment buildings that residents still remembered. And then, in September 2025, less than a year before June 24th, 2026, a doublet of magnitude 6.2 and 6.3 struck west of Caracas. It killed at least one person, injured more than 100, and was notable enough for seismologists to flag. It was a smaller version of exactly what would follow 9 months later. The Boconó fault system does not hide its intentions. It has ruptured repeatedly, at intervals of decades to centuries, across the entire documented history of Venezuela. What it lacks, what it has always lacked, is an early warning system. Unlike countries like Japan, Mexico, and the United States, Venezuela does not have a network of seismic sensors designed to detect the initial, faster P waves of an earthquake and issue warnings in the seconds before the more destructive S waves and surface waves arrive. Those warnings, sometimes 30 seconds, sometimes a full minute, can mean the difference between people still inside a building and people who have made it to the street. Those 30 seconds did not exist for Venezuela on June 24th. And because this was a doublet, because the second earthquake arrived within the shaking of the first, even a warning system might have been able to do very little. The aftermath of the June 24th doublet revealed something that structural engineers and disaster risk experts have been warning about for years. Venezuela's built environment was not designed for this. The high-rise buildings of Caracas, many of them constructed in the 1970s and 1980s during an oil boom that prioritized speed and scale over seismic resilience, were built to standards that have since been revised dramatically. In parts of southeastern Caracas, the pattern of collapse was not random. It followed the age and construction type of the buildings. The oldest, the most densely built, the least reinforced, these came down. Strike-slip faults, like the Boconó system, produce a particular type of ground motion that is especially damaging to structures without lateral force resistance. Rather than vertical motion, the kind people often imagine when they think of earthquakes, strike-slip faults generate horizontal shaking, side to side, the kind of motion that a building designed for gravity loads and vertical weight, but not for lateral forces, is structurally unprepared to absorb. When both earthquakes hit in rapid succession, the first weakening the lateral resistance of every structure it touched, the second arriving before any reassessment was possible. The result was exactly what the engineering models would have predicted: cascading structural failure across an entire urban landscape. The USGS pager service estimated a 39% probability of economic losses between 10 billion and 100 billion US dollars. a 30% probability of losses exceeding 100 billion, potentially equivalent to 20% of Venezuela's entire GDP. That is not just a natural disaster, that is a civilizational setback. The question being asked now, by seismologists, by structural engineers, by governments across the Caribbean and Latin America, is what comes next. There are two parts to that question. The first is immediate, aftershocks. The USGS has stated there is a 99% probability of at least one magnitude 4 aftershock striking Venezuela within the coming week. A 24% probability of a magnitude 6, large enough, in a landscape already compromised by the doublet to cause additional building collapses. Buildings weakened by the doublet but still standing are now in a state of reduced structural capacity. They can absorb less. They require less to fail. An aftershock that would have been survivable before June 24th may not be survivable now. Residents of Caracas who are returning to inspect their buildings are doing so in a landscape where the engineering assumptions have fundamentally changed. The second part of the question is longer term, and geophysicist sources described it clearly. The risks are not over yet. Both faults, the Bocanó system in Venezuela and the San Andreas in California, are along plate boundaries that move in similar ways and have ruptured in enormously destructive earthquakes in the past. The Caribbean and South American plates continue to move 2 centimeters per year, every year. The energy that was released on June 24th was real and enormous, but the fault system stretches for 1,300 kilometers. What ruptured on June 24th was a segment, not the whole. The fault will load again, over decades, over centuries. It has done so repeatedly for millions of years, and it will do so again. There is something quietly devastating about an earthquake doublet that a single earthquake does not produce. With a single earthquake, there is a before and an after. The shaking begins, the shaking ends. And in the silence that follows, people assess. They look at each other. They check for injuries. They begin to understand what has happened. A doublet removes that moment entirely. There is no silence between them. There is no assessment. There is no breath. The people of Caracas who ran into the streets during the first earthquake, some of them were still running when the second one hit. The first responders who began moving toward damaged buildings were still moving when the ground moved again. The volunteers who arrived at collapsed sites in the hours afterward, carrying their own shovels, their own hammers, their own basic tools, describe moving between neighborhoods where buildings had come down, to sites that were overcrowded with help, to sites that had no help at all. The distribution of disaster was uneven and chaotic in a way that stretched every coordination system past its limit. Over 40,000 people are still reported missing as this video is published. The search continues, and beneath the fault, the Caribbean plate is still moving 2 centimeters per year, east past the South American plate. The stress is already beginning to rebuild. It is what it has always done. This is Terrum, and this story is not over yet.